Effects of acid precipitation. So what you can do for me in the meantime is to try to grab some of the main points there. Then I'll give a quick summary of what is stated there. So this section reviews acid precipitate formation and its effects on the environment and ecosystems. Recall that acid precipitation is formed when oxides of carbon, sulfur, and nitrogen found in air react with water present in hail, rain, and snow. Of course, these oxides are formed from burning of various types of fuels, including fossil fuels. The effects of acid precipitation on the environment and ecosystems are manifested in a number of ways. One, there is less productivity in North American lakes. Recall that algae are the producers in all aquatic food chains and are responsible for the sustenance of all aquatic ecosystems. Any factor that impedes algal growth will thus lead to a decline in a number of organisms in aquatic ecosystems. The fact that the waters in these lakes are becoming clearer is indicative of a decline in algal population, which is directly linked to the lowering of the pH in these lakes. Number 2, there is a gradual disappearance of forests around the world. Acid precipitation affects terrestrial vegetations in 2 ways. 1, by direct bleaching of the leaves and other plant structures, and 2, by leaching of nutrients that are essential for plant growth and metabolism so deep into the soil that it deprives the roots of plants from absorbing them. The trees and plants eventually die of various types of deficiency diseases. Number 3, there is receding of coral reefs around the world. Since the bulk of coral reefs is made up of limestone, with calcium carbonate as its main ingredient, and which reacts with acid and gets dissolved in the process, it is not surprising that these reefs are disappearing since the oceans are becoming more acidic. The disappearance of coral reefs represents a loss of precious habitats for a countless number of organisms. Number 4, oh, by the way, this equation here shows how or why coral reefs are getting smaller and smaller. We said that coral reefs is made up of limestone, and a big part of limestone is calcium carbonate, which is a solid, of course. And when these react with any type of acid, they get dissolved in the process. For example, this equation here is showing us how calcium carbonate, if it reacts with hydrochloric acid, it forms calcium chloride, carbon dioxide, and water, and all of these things are soluble in water. That's why coral reefs are getting smaller and smaller, because of the acidity in the water, which is reacting with the calcium carbonate that's found in these reefs. This paragraph also speaks about destruction of soil topography and defacing of some buildings. The same explanation that was given for the disappearance of coral reefs can be used to explain why these are happening. The faces of these buildings and some types of soil are made of limestone like coral reefs, and they thus get dissolved by acid precipitations. And finally, it speaks about the effects of acid precipitation on weight-bearing metallic structures. Of course, acids corrode metals by reacting with them. Recall that when metals such as iron corrode, flaking takes place. If this happens over a prolonged period of time, the strength of the structures that is made of iron can be seriously compromised, causing their eventual collapse. The final subject we want to bring to our attention is the rise in the incidence of cardiopulmonary diseases, especially in densely populated countries. This increase in the incidence of these diseases is closely associated with the intensity of combustion that is happening in these countries. And this brings us to smog formation. So I have two figures here, one on the left and one on the right. The one on the left here shows you what happens normally in air. During the day, the heat sinks on the Earth's surface. The land and water absorb heat from the sun and become warm. The air just above absorbs heat from these, gets less dense and rises. As this happens, denser, cooler air falls to replace areas of low pressure created by the rising warm air. A type of convection current takes place. And there's nice mixing. The opposite happens when there is something that is called an atmospheric inversion. During an atmospheric inversion, what is happening here is that because of certain weather conditions, a layer of cold air is trapped below warm air. See the differences here? Normally you have warm air rising and cold air sinking. When this happens here, it creates some degree of stability for a prolonged period of time. And when it does that, it allows for what is called a smog formation to happen. And in the smog formation, you'll have this gas is called nitrogen dioxide. I've spoken so many times about this, a brown gas, reacting with ground ozone. Ozone that's created above the ground. We'll talk a little bit about that later on. And along with these two and other particles that get trapped inside this stable arrangement here, with energy from the sunlight, what happens is that they undergo something called chemical synergism. And during that process, new compounds are formed that are far more dangerous than ozone by itself and nitrogen dioxide by itself. And these are the compounds that are responsible for the increase in the incidence of all these types of cardiopulmonary diseases. Okay, so I hope that was useful, and I see you next time. Okay, bye.